Hey everyone, welcome to The Explainer. So you're a wizard with SQL, right? You can pull any specific piece of data you need. But what happens when you need to go exploring? Today, we're going to bridge that gap between databases and true data discovery using R.
Right. You've totally mastered your database. You can write that perfect query to get a very specific answer. But what about when the data is brand new? What do you do when you don't even know the right questions to ask yet? That's the real challenge, isn't it? And that's exactly what we're tackling today. So, this really calls for a fundamental shift in how we think. We're moving from just querying to actually exploring. And I absolutely love this way of putting it. Think about it. Exploratory data analysis is basically detective work. Before you can build your big case, your formal statistical model, you have to find the clues first. And that's exactly what EDA is all about. It's about putting on your detective hat and digging into the data. And what's so important to get is that EDA isn't some rigid formula you have to follow. It's more of a philosophy. It's all about getting your hands dirty, interacting with your data, visualizing it, summarizing it, and just letting it surprise you. It's like having a conversation with your data set before you start bossing it around with formal models. Okay, so if we're going to have that conversation, we need to speak the language. Let's dive into R's core building blocks and see how it actually holds on to information.
You're probably thinking, okay, I get tables and columns. How does R store data? Well, let's map what you already know from the database world right onto their R equivalents. It's actually pretty straightforward.
All right, so in the SQL world, you have a table. In R, your main workhorse is going to be the data frame. Just think of it like a single self-contained table that's loaded right into your computer's memory. All the rows, all the columns, just sitting there ready for you to poke and pry. And what about the columns in that table? Well, in R, each column is something called a vector. Now, here's the key rule about vectors, and it's a big one. A vector can only hold one type of data. It's got to be all numbers or all text or all dates. And this rule, this homogeneity, is the secret sauce behind why R is so darn fast with calculations. So we've got vectors for columns and data frames for tables. Just to round things out, I'll mention one more thing. R also has something called a list. Now, if a vector is super strict, only one data type, a list is the total opposite. It's like a flexible shopping bag that can hold anything you want, different kinds of vectors, data frames, even other lists. It's R's go-to for handling more messy, complex data. Okay, we've got the building blocks down. Now, let's get to the fun part, the core strategy for actually summarizing data in R. And let me tell you, this three-step pattern is one of the most powerful ideas in all of data analysis. Seriously. And this is the million-dollar question, right? This is all great, but how can I summarize data for different groups? I'm thinking of something like SQL's group by. If you come from SQL, you live and breathe group by. So how do you do it in R? Well, it turns out R has a really elegant, intuitive way to handle this. It's called the split, apply, combine strategy, and it's as simple as it sounds. First, you split your data into smaller chunks based on some category, let's say year. Then, you apply some function to each of those little chunks. Maybe you want to count the rows or find the average of a column. And finally, you combine all those separate results back into one nice, neat summary table. And once you master this pattern, you're not just making summaries, you're opening the door to all kinds of more complex analysis. And here it is, the side-by-side comparison. On the left, you've got your classic SQL group by query, something you've probably written 1,000 times. And on the right, the R equivalent using the aggregate function. See? They're doing the exact same thing, asking the exact same question, just with slightly different grammar. This right here is the bridge from your SQL world into the world of data exploration with R. All right, so now we've got the concepts down, we've got the strategy, but what's the payoff? What does all this actually let us do? Let's unlock some deeper insights. So you're asking, okay, I see the pattern, so what does this really let me do? Great question. Let's see what happens when we unleash this strategy on a real dataset of scientific publications. Boom, this chart is a direct result of that split, apply, combine thinking. We took a huge table of publications, split it up by year, applied a simple count function to each of those yearly groups, and then combined it all back together into this bar chart. And instantly you see a story, right? A massive explosion in this type of research over time. The key thing here is you didn't have to query specifically for a trend. You just explored the counts and the trend jumped right out at you. And we can get way more specific than just counting. What if, for just one of those years, say 2011, We wanted to find the average significance of all the studies. Well, we just apply an average function instead of a count function to that one group, and we get this, 13.34. See, that's not just a random number. It's a really precise, specific insight that you get when you start exploring, not just querying.
So, you see, this whole thing isn't really just about learning R syntax. It's about shifting your mindset, becoming that data detective. It's about moving beyond just asking for answers you already expect, and instead starting an investigation to find the clues that are hidden in your data, just waiting to be found.
So, what clues are waiting in your data? If this explainer helped you start your own data investigation, help other detectives find their way here by liking, sharing, and subscribing for more. Thanks for watching and happy exploring!